I'm Joanna Church, the Jewish Museum of Maryland's Director of Collections and Exhibits, and it is my pleasure this evening to welcome you to our virtual program, Marylanders Feel the Wonder of Space. Our presentation today is inspired by our exhibit at the Jewish Museum called Jews in Space, Members of the Tribe in Orbit. And at the JMM, we wanted to add some local flavor to this exhibit, and we were fortunate in that the Center for Jewish History, the original creators of the show, allowed us to add and showcase some of Maryland's space science and exploration, the history of it in the state, and the people, whether Jewish or not, who have done that work. It turns out there's a lot of space science, exploration, and education happening all across our state, too much to put on the gallery walls. So we came up with the idea of including a map that would help us to highlight some of these sites. And even then, I had way too much fun researching all the school programs, observatories, planetariums, tech industries, and science fiction hubs, and so many other options. And we had to narrow it down to just 18 points on the physical map in the actual exhibit. But thanks to the companion website, we were able to fit on even more. And if you're looking at the website and you realize I have missed something, please let us know. There's a link down there and you can tell us what we missed and we will make sure to update our Maryland map. And with that, I would like to introduce our moderator for this evening. Julian Atwood is the Director of Public Programs and Visitor Services at the Jewish Museum of Maryland. Throughout her 7.5 years here, she has worked on the development and delivery of all JMM public presentations, such as the one we're about to enjoy tonight. She has a BA and an MA in Egyptology and an MA in Museum Studies. So take it away, Julian.
Thank you so much, Joanna. So in a moment, I will introduce our speakers for this evening, but first, I want to note though the exhibit and the map that Joanna referenced celebrates the myriad of ways in which Marylanders have been inspired by space. Today, we're going to focus on actual space exploration and the way in which humans have sort of historically looked to the skies to try and understand our place in the universe. If you're interested in learning a little more, especially about the science fiction community that is amazing and super active in Maryland today, I would recommend that you watch a recording of a discussion that we hosted a couple weeks ago titled Writing Ourselves into the Narrative. And we'll make sure we'll drop a link to that into the chat section a little later in the program. So with that, I'd like to start to introduce our speakers. I'm going to give a very brief intro, but then I'm going to ask them to give us a little more about their work, because I'm sure they're going to explain that significantly better than I can and likely understand. The institutions at which they work, and what inspired them to pursue a career in space exploration. So up first this evening is Dr. Avi Mandel. He is an extraplanet scientist in the Planetary Systems Laboratory at NASA Goddard. His research focuses on the characterization of extrasolar planets and the formation and evolution of planetary systems, with the specific goal of understanding factors that determine whether a planetary system can form a habitable planet and what the characteristics of these planets will be. So, Dr. Mandel, over to you.
Hi, yeah, thanks. Thanks for the introduction, Julian. So I work, as Julian said, in the Planetary Systems Laboratory, and my primary focus really has been trying to think about exoplanets as a holistic perspective from the concept of a planet as we know of our own Earth and our planets, but also as objects, stellar systems, planetary systems that we observe from very distant perspectives. And so in thinking about planetary systems in that sense, we really get to harken back to some of the amazing ideas that have come to us from science fiction. All of us know about the movies and the books where intrepid explorers fly through space, landing on planets, lots of different types, varieties, conditions, things like this. So we're actually now finally entering the age where we get to think of planets, other planetary systems in the same way that we might have envisioned from previous fiction and movies and books. We're actually able to observe these planets and other systems and their atmospheres using the telescopes, both on the ground and in space, that NASA has helped to build, and that institutions like the Space Telescope Science Institute that you'll hear about soon have helped to run and guide in their missions. And so, in thinking about this, it's a really exciting time to be in space science. And in Maryland here, we have a lot of these scientists who are doing the groundbreaking work in this area and others in space science. And so, as I said, I think it's a really exciting place and time to be here in space science. So thanks for having me. Thanks a lot to the Jewish Museum of Maryland, and glad to be here.
No, we're very pleased you're here, so thank you so much, and thank you. Okay, up next, Dr. Nancy Levinson is the Deputy Director of the Space Telescope Science Institute. She provides leadership and vision for all activities and champions a science-driven approach to support their missions and the communities that they serve. She's also a research professor at Johns Hopkins University Department of Physics and Astronomy. So over to you, Dr. Levinson.
Thank you very much. And it's certainly my pleasure, Trillian, also to be here and to be able to be part of this program. I am an astronomer. I continue to do research in astronomy. And so that's one piece of my working life. I study what we call active galaxies. And so those are galaxies that not only have a supermassive black hole at their center, but that are actively taking on some of their surrounding material. And that process of taking on the material, a lot of energy that we can see as light. And so I tend to study what astronomers consider very nearby galaxies of merely millions of light years away, where we can get very detailed views of them to try to understand what's happening at the centers of the galaxies. So that's a bit about my research side. There's also a good fraction of my time at STSCI is spent looking at the Institute overall, especially to the missions that we're involved with. And so these are NASA missions, largely in collaboration with the Goddard Space Flight Center. For example, Hubble, and coming up the James Webb Space Telescope, and looking ahead even further to the Nancy Grace Roman Space Telescope. So I work closely with our people who work on those missions to make sure that we're able to provide the science support for them, developing the science programs and working with that community. And then one of the other really get to do is to work with our Office of Public Outreach, making the connections with the public community on all of those kinds of space missions. And one of the other things that Trillian had asked about was my inspiration and motivation. And that's a case where I don't have a very good or crisp answer. I don't have a single origin story of how I became an astronomer. And the simple fact is I just liked it. And I kept liking it. As a kid, I would write my fourth grade reports on Mars and carried on in that kind of way. And I kept liking it through college enough to continue to be a professional there. So I will stop there and pass it back to you.
Thank you. And that seems like a very respectable answer, I guess. It's sort of what took me down the path that I went down. So yes, thank you. Okay, so Karen, your institution is a little different. And so your path to space exploration even more so. And so after I've read your intro, I'm gonna really ask if you can give us a very much a better understanding of your site. So Karen Yaffe-Lottes is the program coordinator for the Gaithersburg Community Museum. She's been creating educational programs on themes of history, material culture, and STEM for over 30 years. So over to you.
Thanks, Trillian. So yeah, my background is way different than your other panelists. my background is history and museum education. And I started working at the Gaithersburg Community Museum, coming out of really doing local history only. And the city of Gaithersburg is a caretaker for really an internationally significant site, the Latitude Observatory. And when the observatory was restored in the 90s, it would be open once a year. So then when I came on board as their program coordinator, one of the charges was to find a way to have this place open more than once a year, and to create, you know, a dynamic educational program around that, and for Gaithersburg families in general. So I started out with not much history. I mean, science. I had the history. I knew about Gaithersburg. I knew about Montgomery County. Didn't really know how to be a science educator. It just happened that my husband is an amateur astronomer. He was very excited. And actually the first sky watching programs we had was really basically my husband bringing his telescope to the observatory and letting people look through it. And I actually think that that's the way a lot of people get started in astronomy, as the beginning of a career or as just a passionate hobby. And it is a community. I will say this, it's a community that really wants to share that passion, which makes it easy for someone like me to come in and provide quality programs without having that science background myself.
Okay, so we've very much heard already about just the variety of different ways in which people can get involved in space exploration throughout Maryland. In the exhibit, we suggest that our proximity to DC is a major contributing factor into that sort of variety of options that there are, along with the number of local colleges and universities. But I wonder if, in your opinion, there might be more to it. And especially, Karen, I'm thinking in terms of your institution, which sort of really predates the sort of space race era and such. So I wonder if I can ask you to sort of try and get us started on that one.
So I'll give you a history, a little very in brief history. So the Latitude Observatory was one of 6 observatories that operated around the world from 1899 to 1982, measuring the wobble of the Earth on its polar axis. And it is a bit of a gem that many, many people don't know about. Even people in the astronomy world don't always know what I'm talking about when I mention it. But actually, so the Polar Motion Service is still in existence and still doing what it does. But obviously now we have satellites and we don't need somebody every night going into the building, which is not heated and not air conditioned, spending all night looking at the stars. And I was thinking about your intro because this really was an instance. This is not an observatory like you think of the astronomer looking through the telescope, learning about the stars and the planets. They actually were measuring the distance between Earth and those stars, learning, really trying to learn more about the Earth, because the sort of the study of geodesy was still relatively young and they didn't know a whole lot. And the work that they were doing was trying to learn more about the Earth. So in that sense, it wasn't an astronomical observatory, it's an astrophysical observatory. And when I say observatory, that's very generous because it was really the small, like smaller than my kitchen. And I have a very small kitchen that I'm in. So,
similarly, I want to point out that proximity to the Navy has actually made a really big difference historically to the contribution to space science and the study of both the Earth, the moon, and things like timekeeping, navigation, both on Earth and in the sky for aerospace navigation. So there's a number of different institutions beyond just NASA or sort of space launch services that have contributed to the sort of growth and employment of space affiliated institutions here in the DC area. So they're tangentially related to, quote unquote, the government in DC, but it's much broader than sort of the federal government as we think about down in DC proper. So.
Yeah, and I can just add to that my own institution is following those steps along. So much of the reason that Goddard as a NASA facility is where it is because of some of that DC proximity. And then Space Telescope Science Institute was founded to be a connection to the science using community of the new space telescope, the Hubble Space Telescope. But it was that very reason of being close to the NASA project where the telescope was being designed and built was seen as an advantage, and also proximity to universities. So we're located on the Homewood campus of Johns Hopkins. So both of those things come together with the rationale for why we're here in Maryland.
Right, so finding that absolute sweet spot that brought all of it together. Okay, thank you so much, guys. Okay, so you sort of mentioned them a little bit already, but there are some really exciting projects that are being worked on now by both NASA Goddard and STSCI, which I know we'll be hearing more about them in the news. In fact, I think I saw the New York Times did a piece, was it yesterday or 2 days ago? But I wonder if you can give us a little bit of insight. So I wonder maybe, Avi, if you want to get us started on that one.
Sure, thanks. Yeah, there was this wonderful news article by Dennis Overby. I think the link is now in the chat here about the James Webb Space Telescope. And I'll mention a little bit about that because it's one of our, we call our flagship projects in NASA that's sort of coming close to fruition, finally, after decades of both planning, preparation, construction, testing, assembly, disassembly, reassembly. It's been frankly, a much more arduous process to achieve the level of performance, quality control, and just general sort of construction of this amazing new observatory than I think we had all sort of expected. But it's finally almost here. Everything has been sort of tested, retested, and packaged up. And the James Webb Space Telescope is beginning finally its journey to the launch pad. We're expecting to launch the telescope this coming October, and it's a long process, literally, just to get to the launch pad, because the telescope is so large, even in its packaged state, that it's very hard to ship and move around the country, and let alone the world, because the telescope is actually going to be launched from South America, from a launching pad in French Guiana on one of the French rockets, Ariane 5 rocket. It'll be launched, hopefully. The expected launch is Halloween of 2021. So we're hoping that there's no superstitions that come to fruition as part of that launch. But the James Webb Space Telescope, just in the tradition of the Hubble Space Telescope, is really going to open a brand new vision of the universe, because it's focused in the portion of light, of the electromagnetic spectrum, that we really haven't been able to probe in depth from space so far. And the infrared wavelengths that James Webb Space Telescope will look at really give us an insight into a huge array of astrophysical environments that we haven't really had a chance to probe yet. So everything, Nancy can tell us more about black holes and the interiors and hot gas that's orbiting the largest black holes, the centers of nearby galaxies. We'll be looking at the earliest evidence of high redshift galaxies in the early universe, which have really been only sort of probed in the fuzziest types of pictures that we've been able to see with the Hubble and others. But James Webb will give us brand new insight into these very red shifted galaxies, which really can only be looked at in the infrared, because the light that shines from stars like our sun is red shifted, means the light is shifted so far because of the speed of the galaxies moving away from us. The light from these stars can only be seen in the infrared. And then finally, the area that I work in is planets around other stars, exoplanets. The atmospheres of all types of planets in our own solar system, as well as planets around other stars, these atmospheres are most absorptive and therefore most able to be sort of detected in the infrared. In fact, this is actually why we have such a dominant greenhouse effect on our own planet, is that the atmospheres of planets absorb light in the infrared, just like a greenhouse does on Earth, the heat emission coming from the planet. And so that both serves to warm up planets like our own Earth, and in fact, we think it has played a major role on planets like Venus and Mars in the past, but also serves as a signpost of the atmospheres of planets around other stars that we can sense and detect with the James Webb Space Telescope. So in essence, James Webb will really, change our whole picture of the universe that we see with our eyes to a universe filled with infrared light. But at the same time, James Webb and other flagship missions like that get the most, sort of the lion's share of attention in the news that we see. But NASA Goddard in Maryland, and of course NASA centers all over the country, but NASA Goddard especially plays a role in missions spanning all of the possible science disciplines that you can have from space. So it covers astrophysics missions like James Webb and the Hubble Space Telescope. But NASA Goddard also builds satellites to monitor the Earth and the climate of the Earth, ocean currents and temperatures and hurricanes and everything else you can imagine related to Earth science. NASA Goddard builds telescopes like the Parker Solar Probe, which is right now in orbit close to the sun, monitoring the sun's activity and helping us learn about stars like the sun and how they work. And finally, we help build missions to other planets within our own solar system. For example, the Maven mission, which NASA helped to build and manage, is a mission that monitors the atmosphere of Mars and helps us tell about the history of Mars, the history of water loss, and the climate evolution of Mars over the last 4 billion years. So there's a wide range of missions that we help build and that filter outwards to other institutions within the DC, Virginia, and Maryland area that help to participate in these missions as well. So.
Gosh, Nancy, did you want to add anything to that one?
Sure, I'll just add a couple of things, but Avi absolutely hit many of the highlights of the James Webb Space Telescope, which absolutely we're looking forward to this this year. The thing we always discover what we're not expecting when we have new technology and new capability, and that's absolutely the case here. He mentioned some of the advantages of making observations in the infrared for various types. And so we'll just discover things that we haven't even been thinking of. But in the meantime, even the technology behind this whole mission is so exciting. The primary mirror itself is 6.5 meters across, and that's what we think of as the light gathering power. But that's really big to put in a rocket, so it has to be folded to fit in the rocket for the launch, and then it'll have to be unfolded once it's in space. And we actually want to get away from the Earth's emission, so it's going a million miles away, literally. So that'll just be exciting over the time period when Webb is on its way. So that's one kind of new capability. I do want to say a little bit about the Nancy Grace Roman Space Telescope, which is another one I'm just so looking forward to. Looking forward to launch sometime in the mid-2020s. You can think of it as comparable to Hubble in terms of the level of detail you can get, except that it can view 100 times the field of view at once. So while we have beautiful, exquisite, deep observations with Hubble of tiny patches of the sky, you'll get 100 times that all at once with the Nancy Grace Roman Space Telescope. So again, there are things we just don't know that we're going to that we'll be discovering there. So those are just a couple of future things that I'm looking forward to. And of course, out of obligation, I have to say, Hubble's not gone. I mean, even though we just celebrated Hubble's 30th anniversary, there are fantastic new discoveries coming out of Hubble. So scientists continue to do great things there. And so I'm looking forward to that continuing, and then working in conjunction with these new facilities, because there are slightly different specialized capabilities that each one has.
Wow, so it really is right now sort of just the tip of the iceberg in terms of thinking about what there is to still come, and what amazing discoveries we might be reading about, I guess, in the New York Times in years to come. Thank you. Okay, so one comment, and I should say, Laura, our amazing programs assistant, is dropping various links in the chat as we go along this evening. So there are now links there so you can read more about the James E. Webb Telescope, the Roman Space Telescope, and Hubble as well. So if you're intrigued by any of those particular projects, you can do a little more reading there. So there was a question, Q&A I just thought related to projects. It seems like a nice time to mention it. Is someone asked, will you discuss the Ultrasat project with the Weizmann Institute in Israel and NASA? And I don't actually work with the Weizmann Institute or this particular project, but I did want to highlight that NASA and institutions all over the world, and small colleges, universities, small research institutes, big research institutes like the Applied Physics Lab, APL, which is actually here in Maryland, what's the name? Oh, Columbia, right? Or so Laurel, Maryland, actually. So we have these institutes that build small missions all the time. They're launching every year on whether it's SpaceX rockets or small NASA rockets or Defense Department rockets. And there are amazing opportunities for people to get involved. People, whether they're at colleges or universities, being grad students or undergraduates. I don't know who's on the call today, but if you're interested in getting involved as a student or a university member in one of these missions, there's a lot of opportunities to do that in different institutes. So. Did anybody want to add anything else to that particular project? Any additional background knowledge while we've got that one up? Thank you. So I guess following on quite well from that, hopefully, one of the common elements to the work that all of your institutions do is about engaging with the community. So I guess I wanted to ask what it is about that community involvement in space exploration that excites you the most. And I wonder, Karen, if you can get us started on that one, please.
Well, so for me, I mean, I'm working with the public. I used to be working with the public face-to-face all the time, and we will again. And it's just so wonderful when a kid looks in the telescope and they're like, oh, I can see Saturn. There's just really their sense of excitement. It's incredible, and it makes you just feel really good about what you're doing. I think we all agree. That is the ultimate. And just giving people opportunities in the community, because obviously our audience is not just children, but we have a lot of volunteers, a lot of people who are interested and just not always knowing how to become involved. And so as a community resource, people come to us and they're really excited to get those opportunities, and we're happy to work with them.
Yeah, I'll just add, Karen's absolutely right. I mean, even when I get to look through a telescope and I get to see Saturn, it's still fun. It's still really, really exciting. I think there is a strong sense across a lot of us, especially when we work on these public funded endeavors, of wanting to give back. And so we do want to share with you what we're doing, share with you the discoveries that we're making. And so that's why you do get to see all of those great Hubble images come out, and also learn about the science behind them. It's not just the pretty pictures, but something that we've learned about our universe as a result. So there are those kinds of very public things you can hear about. At the Institute, we also run a public lecture series. So lots of our different scientists speak about what they're working on. That happens on a monthly basis. So that's something you can look for. There's some information at that Hubble site link for it. The other point of getting involved in engagement, I think that's worth mentioning, even on a sort of professional capacity, is at an organization like mine or at NASA. It's not only scientists. There are all kinds of people who are absolutely involved in making this work. I mean, there are all different kinds of engineers and software engineers and people who work on IT systems and lots of different kinds of things that are contributing to this whole project. So that's another avenue to think about.
Thank you. Avi, did you want to add anything?
Yeah, I think as everyone has said actually multiple times, is we're drawn to space. We're drawn to the exploration, the discovery, the unknown. All of us here on this line and millions of people around the world, just they can't quite explain what it is, but there's this pull and this draw. And I think those of us who are privileged to be able to work in the field and to be able to either discover new things or to spend our days thinking about how to share what we learn. I think it's really our duty, in a sense, to really try to bring as many people into the process, the joy, the journey of discovery as we reach farther and farther out with our missions, with our telescopes, with everything we do. And so I think anyone who gets into space science or space research or space education really wants to give back, in that sense, the same joy that they get from being able to do this. So.
Brilliant. Thank you so much. Okay, I actually want to sort of lean into a little something there that Nancy said a minute ago. So as a group of individuals that work in science and have I think a better you do clearly have a much better understanding of the field and all the different roles that are involved. I wonder, knowing what you know now, is there a different career within space exploration that you maybe wish you could have pursued, or just one that, always fascinates you? Who did we say was maybe Avi, do you want to get us started on that one?
Yeah, absolutely. I mean, again, as someone who, sort of has this huge passion for exploration and space and understanding our own planet as well as other planets, there's a lot of different areas, a lot of different jobs that really are exciting to hear about, even, when you work at NASA to hear about things that people are able to do. Something that has really intrigued me recently has been what we call planetary protection in this sense. So NASA has started thinking a lot about what it means to sort of protect our own planet on a cosmic sense, and our own, the civilizations, the environments, and the people on our own planet in a sort of from cosmic threats in this sense. So it sounds straight out of science fiction. In fact, there was quite a hubbub that happened online when NASA actually advertised the position of Planetary Protection Officer, because it sounded like someone who would use lasers to shoot at aliens or something like that. But frankly, it's a real question in two directions. One of which is how we protect our own planet from threats like asteroids. There are millions of asteroids, both big and small, in our solar system, many of which we have not yet even discovered because they're so small or so distant that we don't know about them, and their future orbits and trajectories could actually end up impacting on Earth and causing destruction on the scale of what may have killed the dinosaurs or caused other mass extinctions in the Earth's past. And so now that we are finally building the resources and the potential to scan our solar system for threatening objects that may in the future come to impact Earth, we're trying to decide what's the best way to build out our ability to save our species and every other species on Earth from a potentially extinction event. But then at the same time, we have to think about potentially contaminating other planets when we bring our own species and our own biology to the surface of other planets. For example, when we first land humans on Mars or other spacecraft or complex systems, there may be the potential to bring bacteria or other contaminating life forms to the surface of other planets. So thinking about these sort of intricate questions about how we both protect our Earth and protect others is a job that really intrigues me. If I had a different background or a different perspective, it would be really interesting to tackle. So.
That sounds fascinating. Gosh. Nancy, as you sort of started heading in that path a little bit before, do you want to go next?
Sure, I'll jump into that one. With the sort of research that I do, everything is very remote sensing, right? We're waiting for the light to come to us from these objects. And we do a great job with it. We can discover all kinds of things about them while we're here on Earth or with our telescopes in space. But if I think about something that would be a different way to explore the universe, I do think about the solar system exploration where people actually capture material from these other bodies. So capturing moon rocks and capturing material from asteroids and really bringing them back to the laboratory and being able to work on those things back at home. That would just be a very different way of working, yet exciting and in its own way. So as I think about what would be an alternate path that would tap into different kinds of ways of learning about the universe, for me, I think it would be something that brings a little bit of a physical connection to those objects of study.
Right, absolutely. Okay, Karen?
Well, it's a little different, but I suppose if I had been in a technical field, I might have thought about something along Nancy's lines, sort of that astrogeologist, I think is what they're called. I think that would be pretty fascinating.
Fantastic, thank you. Okay, we are running out of time, so I'm going to ask one more question in a moment, but those of you in the audience, if you have questions for any of our speakers this evening, please use the Q&A function that you should be able to find. If you're on a computer, certainly at the bottom of your screen, if you're on an Apple device, the top, and submit your questions using the Q&A function. Those of you joining us on Facebook, if you can just pop your questions into the comment section and our tech team will make sure they make their way over to us. Okay, so recognizing that a large part of the work that your organizations do is intended to enable others to get an opportunity to start to explore space, I wanted to ask if you could perhaps tell us a little about the opportunities that people can get involved in right now during this sort of COVID era. So I guess, Karen, you want to get us started on that one?
Well, there are so many citizen science opportunities. Like you can study Hubble data, and people have found things through those Hubble images that the scientists haven't seen. It's pretty exciting. I think one just recently, somebody found something just looking at this. And I mean, in our area, there's so many different groups. There's a lot of astronomical societies, you know, just around here, there's Northern Virginia, there's the National Capital, and we have programs, not monthly at the moment, but actually because of COVID, we've been able to do some winter talks that usually our schedule is April to October, but for instance, coming up for the Perseverance landing, we've partnered with the Rockville Science Center, and we're gonna have talks and landing watch party. You know, these are things we absolutely wouldn't do. It was like, astronomy was April to October, and then everything else was the rest of the year. So there's just so many opportunities now.
I definitely understand how our current situation has made us rethink what offerings we have as museums, but I think very much for the better. So,
yeah, I mean, I do think, you know, there's nothing like looking in a telescope yourself, but it has certainly opened up a lot of possibilities that we didn't have before.
Thank you. Nancy, you want to go next?
Sure. So I'd already mentioned the public lecture series, and so that's an obvious kind of thing that can carry on in this remote way. And it is interesting that it really has enabled more people to participate. People who couldn't come to see them when they were in person. So reaching a wider audience there. Some of our other public programs are continuing, again, completely remote. Youth for Astronomy and Engineering, that's carrying on remotely. So those are a few things. I'm certainly looking forward to, with the James Webb launch in October, we hope that there will be more public kinds of events. Even if we're somewhat restricted as we are now, there are lots of outdoor things we could do to appreciate that scale. So that's something to keep an eye out for in the future. One of the things that Karen mentioned, it's not at all specific to our institution, but is worth publicizing, an organization called Zooniverse, which is actually a gateway for a lot of these public science or citizen science programs, where just if you're interested, you can participate, you can do things to contribute to a research project that someone is doing to better understand features on Mars or galaxies. So that's just something fun to know about. I'll pop the website into the chat.
Thank you.
And
Avi.
Yeah, so similar. So NASA headquarters has actually gotten very engaged in citizen science over the last year or so. You can actually go to the citizen science website for the Science Mission Directorate at NASA, And they have a full list of projects across all of the different NASA science divisions, and you can click and find out more about them. I think there's two things that really have come together to make citizen science really exciting. One was, frankly, kind of the video game industry and the sort of proliferation of what's called gamification of almost everything online right now, which is the sort of recognition that if you make something fun and interesting and like a game, the same things that draw us into video games, you know, the ability to sort of win levels and to find things and to sort of have that kind of fun within a virtual space can be applied to science in the same way. And so, so this has really been adopted. And frankly, some of the people who worked in video games have come to help and work on these citizen science websites and projects at NASA and elsewhere. And then the other sort of recognition is actually from scientists themselves, which is that there's certain projects that really, you know, you could put a computer to work crunching away, maybe even artificial intelligence to kind of, you know, handle things. But the human brain is really, you know, unique and special in areas that really computers can't do very well yet. Things like pattern matching in complex scenes, or, you know, identifying things that are false positives, ruling them out in a way that a computer would flag and cause the scientists to spend hours and hours and hours wading through false results. So putting these things together, citizen science websites have really sort of given the opportunity for discovery in a way that is really essential and leverages, you know, thousands to millions of people putting their brains to work on projects that couldn't be done otherwise. And so I really encourage everyone to go, you know, to some of these things that have been put into the chat here, and to just try it out and participate, because you'll find that it's both fun and interesting. And then as Karen said, I think, or Nancy said, you know, people often end up on science papers if they do enough of this citizen science work, because it is essential to the scientists who have built these websites and these projects. And it's real science that can end up in publications and at conferences. So yeah, it's an exciting time.
That's brilliant. I look forward to inviting a couple of years down the line, someone in the audience right now back to present on their research inspired by the program this evening. So
Exactly.
keep an eye out, everyone. Okay, okay, we got a few questions in. How long does it take for an image to be transmitted back to Earth from Hubble? Who wants to take that one?
T, do you want to jump on that?
Sure, I can jump on that. So the actual transmission time, the thing that takes a while is just to take the time traveling over the distance. So it's really just a few minutes. Although Hubble isn't transmitting back continuously, got to wait until we're in the right spots to over the systems to transmit back down. So the real time lag on this is the light travel time, waiting for the light to travel over those hundreds, thousands, millions, even billions of years from those objects to get to us.
Yeah, but I also want to mention that the James, as Nancy said already, the James Webb Space Telescope will be in a completely different orbit than the Hubble Space Telescope. Hubble orbits the Earth, and so in fact, you know, it's relatively close by. It's, you know, skimming the sort of apple skin of Earth's atmosphere, essentially. And so, so the transmission time is quite short, but the James Webb Space Telescope will have a much longer distance for the light waves to travel. And similarly, we'll also have these orientation issues that Nancy is mentioning about Hubble. So it's much more complex for James Webb to transmit its data back, and we'll have to wait a little bit longer. So.
Interesting. So I guess a follow-up, and I wonder if we can potentially apply it to both Hubble and James Webb, is who actually decides what they're looking at? Where does that decision come from? And is it different for the two separate telescopes, I suppose?
So I can answer that one since that's an area where Space Telescope Science Institute is very involved in setting the science program. Ultimately, it comes through a peer review process of scientists themselves. So the time available is open, advertised to everyone, advertised to the public. There's a process you need to go through to write a proposal to describe what you would like to look at, exactly how you'd like to do it, what science you'll learn from it. And then all of those proposals on an annual basis are evaluated by experts in the field to come up with the final science program. So that's how it's done. And as you might expect, the requests greatly outnumber the available time. So there are lots of people who apply and don't get the time that they're looking for. But another piece of it that's actually useful is, so that's deciding what those telescopes will look at, but then the data do become publicly available, again, to everyone. You don't even have to expert, but all of the data are available for the community and archives where those can be obtained.
That's fascinating. I never would have imagined for a moment that was an option to submit a request like that.
It takes let's just say a little bit of practice and study to submit. But frankly, Nancy's right. Anyone in the world, not even in just the U.S., but anyone in the world can submit a proposal to the NASA Space Telescopes and receive the time. So, yeah.
Okay. Next question then. How does government funding changes affect your projects, and have any projects ever been stopped and then restarted down the line? Who wants to take that one?
So I can take that. Yes. So all of NASA's projects, especially in space science, but also in human exploration, are all funded exclusively from the federal government's budget in this sense. And so as the budget oscillates, ebbs and flows with each year, with Congress making decisions on what sort of priorities should be given the most funding each year, there's more or less pressure on NASA to fund different types of projects. So the sort of general answer is yes, our funding for all of NASA's projects ebbs and flows. But on a project by project basis, there's actually a very set and specified sort of procedure. Once a project is selected for development, it goes through a number of what are called key decision points in the project. And so these are points where the project engineers have to essentially present their progress, the challenges that they've overcome, the readiness of each of their subsystems, their instruments, their flight dynamics. They have to present these things to review boards, and they have to be given essentially the go-ahead to continue their project development. NASA headquarters officials are involved in these reviews. So it's a very sort of rigid and standardized process that these projects have to go through. And yes, it has certainly happened that they have not passed these reviews, or they have ended up going far over the budget that was specified for the project in the first place. And when these reviews come up and they get a negative review, the project can be canceled. And that's happened a number of times in the past. The bigger the project, things like the Hubble Space Telescope or the Webb Space Telescope, or the landers that have landed on Mars, they're given somewhat more leeway because NASA headquarters and Congress know that they are technologically revolutionary and extremely challenging. And so, if the budget grows or challenges come up, these projects, are given new chances to overcome these challenges. But even these projects, risk being canceled either due to budgetary, the sort of winds of budgetary challenges, or to technological challenges that cannot be overcome. So.
Thank you. Did anyone want to add anything else? No, sounded. Nancy, did you want to add anything on that one?
No, nothing to add on that one. There was another question that had come up in the chat that someone had asked about. Is there a place to see a list of projects that are approved? And so I dropped a website in there, which is a place that you can follow that, along with a link to the Mikulski Archive for Space Telescopes, which is where the data go.
Fantastic, thank you so much. Okay, yeah, Karen, we've got a question for you. Is there a reason that Gaithersburg was chosen as home to one of the Latitude Observatories in the 1890s?
So all the Latitude Observatories are on the 39 degrees 8 minutes. And the Japanese actually were leaders in the program, and they had an observatory at Misuzawa, Japan. Hopefully I said that right. And so they picked that latitude to coincide with the Japanese observatory. So there were actually originally 3 in the United States. There was already an observatory in Cincinnati that was on the right latitude. And then Gaithersburg was built, and then there was one in Ukiah, California, and then Japan, and there was one in Russia and one in Italy. And they didn't all operate, continuously. Budget things, world wars, kind of got in the way. But actually during World War II, the observers were still making observations and recording their data. And then it all came together after the war. So the war didn't actually stop that from happening. So it just happened that the person who was put in charge of it, so the Coast and Geodetic Survey oversaw the observatories that were in the United States. Every country was responsible for their own, even though it was part of the international committee. And the head of that office responsible for the observatories lived in Rockville. So first he had one in his backyard, and then Rockville was too bright in 1899. So he went out into the wilderness of Gaithersburg. So if you know Gaithersburg, then it's funny.
Fantastic, thank you. Okay, I want to ask one other quick question, because we're very, very nearly about to run out of time. But I do want to ask your advice. Recognizing that we've got a lot of sort of space enthusiasts with us this evening, I wanted to ask how we as non-scientists can aid in the further growth of the field, either supporting our children, grandchildren, members of the family pursuing careers in space or in STEM, or just generally as Maryland residents, like what can we be doing to support your community? So I guess, Nancy, you want to take us away on that one?
Sure, I'm happy to start. And there are a couple of different ways at different levels, and so I'm glad you mentioned that point about supporting your family, supporting people you know, just to encourage those interests, right? Especially from a young age, I think that kids are just naturally scientists. They're curious, they want to understand, they explore, and so to be able to encourage that, and as you learn about these other resources that are available to help them to be able to explore in the way that they want. And then on the other side, I will say that it's honestly very important that the public values this kind of space exploration at the level that I've mostly been talking about at the NASA sorts of missions. I mean, yes, this is a very expensive thing to do. We're asking for a lot of public money to be able to do that. I think the return is worthwhile, but it really does need continued public interest and public support. And so just having that kind of interest and that kind of interest in science overall is worthwhile. So I just appreciate that kind of positive feeling that we've got from the public.
Thank you.
Yeah, I'd just like to agree, you know, with everything that's been said. Also, you know, just to kind of, there's this, all of our, as I said earlier, about missions and frankly, all of our observatories, often planetariums and science centers, all of these are funded by, you know, well, actually there's more and more private financing for some of these things, but there's so much public financing that is needed for supporting science across the country of all different kinds, but especially space science in the many ways we've talked about. And this starts with you, with all of us, really, you know, making our enthusiasm clear. But it also really comes down to electing and supporting our representatives who really support these types of science endeavors as well. I can tell you from, you know, the types of meetings and outreach that we have with Congress members and even with state representatives that, you know, there's a lot of enthusiasm from certain elected officials for these types of projects. And, you know, that can really make or break the types of things that we are sort of able to have supported from Congress and from our own administration. And so, you know, if you're interested, if you're excited in space, make that known to the people, you know, that are in elected office and just, you know, support it in the way that Nancy is saying. Show your excitement. So.
Thank you. And Karen?
Well, yeah, I mean, I just have to say all of that. But, you know, for the parents out there, even if you are not interested in science, if your kid is, there are just so many things that you can do in this area, things that are open, that are free. I mean, we live in an incredible area, you know, that, so for instance, all the sky watching programs we have at the observatory, they're always free, and there's lots of things for the kids to do, for anybody to do hands-on besides looking through the telescope. And I think that if it doesn't take much to just try and encourage that level of enthusiasm in your kids to keep it going.
With that, we have pretty much, well, a minute ago actually, ran out of time. So just before we totally wrap up for the evening, we're going to drop a few more links in the chat there for you. So we will drop in there links to access the Maryland map that we mentioned earlier that accompanies our exhibit, that shows you all of the sites with connections to space. And as a reminder, there is a way in which if something you know of is missing, you can submit that and it can be updated. We'll also drop in a link to see the recording of our program from a couple of weeks ago, Writing Ourselves into the Narrative, with Maryland science fiction writers. We'll also drop in a link where you can find out more about some of our upcoming events at the museum, and also recordings of some of our prior programs in this series. Great if you go and have a little check those out. We're also going to drop in some links where you can learn more about the Gaithersburg Community Museum, NASA Goddard, and STSCI, along with all of the amazing links that are already in there. So I promise we'll stick around for a minute so you can get all of the links that you would like. And then I would just like to say thank you so much. Thank you so much to Dr. Levinson. Thank you so much to Ms. Lutters. And thank you so much to Dr. Mandel for taking us through this and just giving us such a brilliant insight into this world in which you are able to work. It is just fascinating, and I really hope, I'm certainly feeling very inspired, and I hope the same can be said for our audience as well. And just finally, I'd also like to say thank you to Joanna for doing the intro today, and thank you to Laura, who has been handling all of the links today. So thank you very much, everyone. And we very much hope we'll see you again soon. Have a good evening, everybody. Thank you.